Okay, today we are in notes number 23, and the topic is physics applications. So we've done a variety of applications, or story problems you might like to call them, throughout the chapter, just a little bit of this and a little bit of that. And today we're going to focus on one type. So this is when you have an object that goes up and then comes back down. And what we're focused on in today's problems is the vertical position of the object. So not the horizontal, but the vertical. And when you take physics someday, you'll learn how to break it down into a vertical component and a horizontal component and break down the velocity into two components. But we're just focused right now on the vertical up and down. Okay? So there are some formulas that we need to know. And for today, you just kind of have to memorize these formulas or accept them, but when you get to calculus, you'll learn how to prove them. So we're going to let the letter t, lowercase t, stand for time. And for the position or height at time t, we typically use s of t. Now in your book, we did some problems. I think there was like an egg dropping and some other things dropping, and it used h of t, h for height. That makes a lot of sense. It really ultimately doesn't matter if it's S or H, as long as the concept is the same. So the position at time 0 is going to be known as S naught. Naught is N-A-U-G-H-T, means nothing. And so we use that as our subscript. S naught is position at time 0. Velocity at time t will be v of t, and velocity at time 0 will be v naught. Now for direction, up is going to be the positive direction and down is going to be the negative direction. So if something is going upward, it has a positive velocity, and if it's going downward, it has a negative velocity. We use the letter G in general to stand for the acceleration due to gravity. But if you're working in meters and seconds, then the acceleration due to gravity that we will use is negative 9.8 meters per second squared. And if you're working in feet and seconds, the acceleration due to gravity we'll use is negative 32 feet per second squared. It's negative because it's a downward force, and remember we said down is the negative direction. Alternatively, a person could do these problems using positive numbers there if you consider down the positive direction. I think we should try to do it the same way for the sake of simplicity here in this class. So to get the position of the object, S of t, in general, it's going to be 1/2 of the acceleration due to gravity times time squared plus the initial velocity times time plus the initial position. So see, that's a quadratic function because you have t squared in there. That's how this whole idea fits into our chapter. And in general, the velocity of the object, v of t, is going to be the acceleration due to gravity times time plus the initial velocity. So therefore, if we're working with meters and seconds, the position in meters is going to be S of t equals negative 4.9 t squared plus v naught t plus s naught. See, I took half of negative 9.8, and that's where we got negative 4.9. And then the velocity at time t is going to be negative 9.8 t plus v naught. And if you're working in feet instead of meters, then the position is going to be S of t equals negative 16 t squared plus v naught t plus s naught. And the velocity, v of t, is negative 32 t plus v naught. Okay, so once we have those equations, we're going to go ahead and apply them. And we're going to work through two different example problems here. And each example problem has a variety of parts. So here's number 1. A football is thrown upward with an initial velocity of 60 feet per second from a height of 6 feet. Now those numbers might not be incredibly realistic. That's okay. We can do the math even if the numbers aren't completely realistic. And we're giving exact simplified answers. So doing these problems not only helps us to practice with quadratics, but it's a great opportunity to practice simplifying and keeping things exact even when they're complicated, because the numbers do not usually work out to be very user-friendly in these real-world examples. So I'm going to model for you how to keep everything exact and mathematically accurate. Then we're also going to approximate answers and round those to the nearest tenth. Okay, so let's get started. I'm breaking this up into different slides, but for the whole problem, let's go ahead and find our position equation. Notice that the units are feet, so let's make sure we use the equations that involve feet. The position is going to be s of t equals negative 16t squared plus 60t plus 6. Notice I substituted 60 in for the initial velocity and 6 in for the initial height. And then the velocity equation is v of t equals negative 32t plus 60. Okay. So part A says, when will it reach the peak of its flight? So you have to remember that this ball is going up and down like a parabola, and the peak is going to be at the vertex. So the x-coordinate is going to be the time, and the y-coordinate is going to be the height. So we need to find the time, the x-coordinate of the vertex. And we know how to get the x-coordinate of the vertex. We use the opposite of b over 2a. So let's go ahead and take our equation and look for the values of b and a. b is 60, so we have negative 60, and a is negative 16, so we have negative 32 for 2a. And this reduces to negative, or I guess we can cancel the negatives, so this reduces to 15 eighths, sorry. Divide the top and bottom by 4. Okay, so for part A, when will it reach the peak? We know the time now is 15 eighths. So it reaches the peak at 15 eighths seconds. That's almost 2 seconds, 1 7/8. What is its maximum height? Well, that would be the y-coordinate of the vertex. So we know that to find the y-coordinate of any point, you take the x-coordinate and you substitute it into the equation. So the y-coordinate at 15 eighths would be negative 16 times 15 eighths squared plus 60 times 15 eighths plus 6. So if you're working this out by hand, you're going to square the 15 and the 8, and then you can reduce. I would actually not spend a lot of time doing this part by hand because the calculator can do all this fraction work for you. So let's review how to do that. And by the way, let's be clear that I'm not saying that it's not important to be able to do fractions yourself. I'm just saying it's good to choose an appropriate tool for the time being. And at times you should do things on your own, but at other times it's important just to know when to grab your tool. So we have negative 16 times 15 eighths squared plus 60 times 15 eighths plus 6. Now if your calculator gives you a decimal and you want a fraction, remember what you can do is press math, and then number 1 is changed to fraction, and then press enter. Now for this problem, I don't think we want the improper fraction. I think it would be better to have 62 1/4, but 62.25 is still exact. So I'm just going to say 62 1/4 feet is the maximum height. Okay, let's check out part C and D. When will it be 20 feet high? Okay, remember we have our equation. S of t equals negative 16t squared plus 60t plus 6. And we want to know the time, find the time. when s of t is 20. So let's just substitute 20 in there. So here's the quadratic equation we need to solve. Let's subtract 20 from both sides because most of the methods we use to solve quadratic equations involve having a 0. Let's divide both sides of the equation by -2 just to make the numbers easier to work with. But still, this is not a very user-friendly equation, especially if you're going to try to factor it or something. So let's just go ahead and use the quadratic formula. Or if you prefer completing the square, you could do that. So we have the opposite of b over 2a, which, by the way, is going to be your 15/8 that you had earlier. Remember when we found opposite of b over 2a earlier, it's still the same thing. Plus or minus the square root of b squared minus 4ac over 2a. So 15/8 plus or minus, let's see what we get for 900 minus 4 times 8 times 7. And what do we call that quantity inside the radical? That's right, the discriminant. So it's 676. And then what you're going to do is see if you can simplify that radical, see if there are any perfect squares that divide into 676. So I would start by dividing by 4. Yep, that works. It's divisible by 4. It's 4 times 169. And unless I'm missing something, I think that's about as good as it's going to get. So we have 15/8 plus or minus 2 square root 169 over 16. Let's reduce that to 15/8 plus or minus square root 169 over 8. Okay, now let's find the approximate values of both of these using the calculator. 15/8 plus square root 169 divided by 8 is 3.5. Oh, is 169 a perfect square? 169. Could that have worked out so nicely? I don't think so. Oh, it is. It's 13. Well, would you look at that? Silly me. I did not expect that to happen because I just made up these numbers randomly. That is pretty cool. Have you been screaming that at me for a while? So 676 is a perfect square. 26. Okay, so I just have to go back, and now 15/8 plus 13/8 is going to be 28/8. 15/8 minus 13/8 is going to be 2/8. So then let's reduce those, and we have 14. Nope. What am I doing? Divide by 4. We have 7 halves, and we have 1/4. Does that look right? Okay. So there are 2 times when the football is at a height of 20 feet. Does that make sense? It starts at a height of 6. It goes up and down. And what was the maximum height again? It was 62 and 1/4. So yeah, it's going to reach a height of 20 feet 2 times. Once on its way up and once on its way down. And remember the units there, we have seconds. 1/4 of a second, that's when it's on its way up. 7 halves, 3.5 seconds, that's when it's on its way down. And then part D, when will it be 80 feet high? Okay, stop and think about this. What's the maximum height? 62 1/4? So we just say never. It's never reaching 80. Okay, let's wrap up this problem. The next 2 questions ask about velocity. So remember we had the other equation, velocity equals, what was it? Negative 32t plus 60, right? So at 1 second, velocity of 1 would be negative 32 times 1 plus 60, and that would be 28. 28 what? 28 feet per second. Does it make sense that that is positive? Remember we said positive would be the upward direction, and at 1 second, is it on its way up? Yeah, remember it reaches the peak at 1 7/8 seconds, so at 1 second it's still on its way down. So we should know what to expect for part G, the velocity at 3 seconds. We should expect it to be negative because we know it's going to be on its way down. So that's going to be negative 96 plus 60, negative 36 feet per second. Okay, so that's number 1. Obviously, it takes a long time to do each problem. I'm going to end this video, and then I'm going to do one more example as part 2, a new video.